65 million years ago, an asteroid struck the Yucatan Peninsula with the force of 10 billion atomic bombs. The impact vaporized rock, ignited forests across continents, and shrouded the planet in darkness. When the dust finally settled, the age of dinosaurs had ended. We know this happened because the evidence remains. A thin layer of clay, buried in rock formations around the world, contains concentrations of iridium 30 times higher than normal. This rare metal, abundant in asteroids but virtually absent from Earth's crust, marks the precise moment of catastrophe. 65 million years later, we can still read the signature of that single day written in stone. But here's the unsettling question. If the geological record preserves such clear evidence of a brief, violent event from the deep past, what else might it preserve? What if advanced technological civilizations rose and fell on Earth long before humans existed? What if we are not the first intelligence to split atoms, melt metals, or alter our planet's atmosphere? And what if geological time has hidden their traces so completely that we've been walking across the ruins of their achievements without ever recognizing them? This is the premise behind one of the most provocative ideas in modern science, a hypothesis that forces us to reconsider everything we think we know about our place in Earth's history. The story of life on Earth should be written clearly in stone. Every species that ever lived, every evolutionary transition, every adaptation and extinction should leave fossils that tell us how we got here. The fossil record should be a complete archive, a 4 billion-year encyclopedia of biology. Instead, it reads like a book with most of its pages ripped out. What remains are fragments, tantalizing hints of chapters we cannot fully read. Paleontologists have long struggled with these gaps, but the word gaps fails to capture their staggering scale. Consider the Cambrian explosion. 540 million years ago, complex life forms appeared suddenly in the fossil record. Before this event, we find mostly simple single-celled organisms drifting in ancient seas. After it, the oceans teemed with creatures possessing eyes, shells, articulated limbs, and sophisticated body plans. This transition should have taken millions of years of gradual evolution, an accumulation of small changes building toward complexity. Instead, it happened almost instantly in geological terms. One moment, Earth hosted simple life. The next, it was home to an astonishing diversity of complex organisms. The fossil record offers no explanation for this dramatic leap. Traditional explanations point to preservation bias. Soft-bodied organisms rarely fossilize, so we might be missing crucial evolutionary intermediates. Environmental conditions affect fossilization rates, creating apparent gaps where gradual change actually occurred. These factors certainly play a role, but some gaps seem too systematic, too precisely timed to result from random preservation failures. They coincide with dramatic changes in atmospheric composition, ocean chemistry, and global climate patterns. Changes that suggest something beyond normal evolutionary processes was occurring. 2 billion years ago, oxygen levels in Earth's atmosphere increased dramatically in what scientists call the Great Oxygenation Event. This transformation poisoned most existing life forms while enabling new types of organisms to evolve. The event fundamentally altered the planet's chemistry and biology. Scientists attribute it to cyanobacteria beginning to produce oxygen through photosynthesis. But the timing and scale of the change seem remarkably abrupt for a natural process. The oxygen increase follows a pattern that resembles what might happen if an advanced civilization began manipulating atmospheric chemistry on a planetary scale. Similar patterns appear throughout the fossil record. Periods of stability interrupted by sudden dramatic changes that reshape life on Earth. Mass extinctions followed by rapid diversification of new species. Chemical signatures in rock layers that suggest massive coordinated alterations to planetary systems. What if some of these gaps represent periods when previous civilizations dominated the planet? Their industrial activities might have altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil record. The rapid emergence of new life forms might represent evolutionary responses to changed conditions, or something else entirely. The idea emerged from a thought experiment proposed by scientists studying Earth's deep past. They named it after an ancient species from science fiction, but the question it poses is deadly serious. Could industrial civilizations have existed on Earth long before humans, leaving behind traces so subtle or so transformed by geological time that we simply haven't recognized them yet? Consider the scale of deep time. If a human-like industrial civilization lasted 10,000 years and then vanished, that period would represent just 2/10,000ths of 1% of Earth's 4.5 billion year history. Finding evidence of such a brief period would be like searching for a single page in a library containing 4 million books. But evidence should exist. Every industrial civilization must consume energy, alter atmospheric chemistry, and produce waste products that persist far longer than buildings or machines. These signatures become part of Earth's permanent geological record, preserved in rock layers, ice cores, and sediment deposits. The challenge lies in recognizing these signatures. We know what modern industrial activity looks like because we are creating it right now. We pump carbon dioxide into the atmosphere, scatter plastic particles across the globe, and produce radioactive isotopes that will persist for thousands of years. Future geologists would easily identify our impact on the planet. But what if previous civilizations used different technologies? What if they harnessed energy sources we haven't discovered or developed materials that decay differently than our plastics and concrete? Their industrial signatures might be hiding in plain sight, misinterpreted as natural phenomena. The iridium layer proves that Earth preserves evidence of dramatic events across vast spans of time. If the planet can maintain a record of a single day when an asteroid struck, it should also preserve traces of civilizations that might have thrived for millennia. Scientists began examining the geological record with new eyes, searching for patterns that might indicate ancient industrial activity. What they discovered challenges our most fundamental assumptions about life on Earth. Every factory, every power plant, every piece of heavy machinery leaves chemical fingerprints that persist long after the structures themselves crumble to dust. These signatures become incorporated into Earth's geological record, creating permanent evidence of industrial activity that can survive for millions of years. Modern industry produces distinctive isotope ratios that differ dramatically from natural processes. When we burn fossil fuels, we release carbon that has been locked underground for millions of years. This ancient carbon has a specific isotopic signature that shows up clearly in atmospheric measurements and gets preserved in tree rings, ice cores, and marine sediments. Nuclear weapons testing created radioactive isotopes that appear nowhere in nature. These artificial elements will remain detectable in geological samples for thousands of years, providing future scientists with unmistakable proof that an advanced technological civilization existed on Earth during the 20th and 21st centuries. But geologists have discovered similar anomalous isotope signatures in rock layers that predate human civilization by millions of years. The Permian-Triassic boundary, marking the greatest mass extinction in Earth's history 252 million years ago, contains carbon isotope ratios that mirror exactly what we see from massive fossil fuel combustion. The scale of this signature suggests an event that released carbon equivalent to burning all known coal, oil, and natural gas reserves on Earth within a relatively short geological time span. Traditional explanations invoke massive volcanic eruptions or methane releases from warming oceans. These natural processes could certainly produce carbon anomalies, but the precision and magnitude of the isotope ratios bear an uncanny resemblance to industrial-scale burning. Ice cores from Antarctica preserve atmospheric samples stretching back 800,000 years. Within these samples, scientists have identified periods of rapid atmospheric change that resemble what we might expect from large-scale industrial activity. Concentrations of greenhouse gases spike suddenly, remain elevated for thousands of years, then return to baseline levels. These patterns appear multiple times throughout the ice core record, always preceded by subtle changes in atmospheric chemistry. The changes are too rapid and too systematic to result from known natural processes alone. Rock formations in Colorado contain microscopic spheres of titanium and other rare metals arranged in layers that correspond to specific time periods. These spheres are identical to particles produced by high-temperature industrial processes, yet they appear in geological strata that formed long before humans developed metallurgy. Similar metallic anomalies have been discovered in sediment cores from deep ocean basins. The metals are distributed in patterns that suggest widespread atmospheric dispersal, as if they were released by numerous industrial sources operating simultaneously across different continents. Ocean sediment cores reveal concentrations of synthetic compounds that should not exist in nature, yet they appear in geological contexts that predate human chemistry by enormous margins. These chemical signatures could have natural explanations we haven't yet discovered. Earth's geological processes are incredibly complex, and we may be misinterpreting evidence of unusual but natural phenomena. However, the patterns are becoming too numerous and too systematic to ignore. Plastic will be humanity's most enduring legacy. Long after our cities crumble and our bones turn to dust, microscopic plastic particles will remain embedded in sediment layers, providing future geologists with unmistakable evidence that an industrial civilization once dominated this planet. Plastic breaks down extremely slowly in natural environments. Even when exposed to sunlight, heat, and chemical weathering, plastic fragments persist for hundreds or thousands of years. In deep ocean sediments or frozen environments, plastic could remain virtually unchanged for millions of years. This durability makes plastic an ideal geological marker. Future scientists examining Earth's sediment layers will discover a sharp transition where plastic particles suddenly appear in enormous quantities, marking the beginning of what geologists might call the Anthropocene epoch, the age when humans began reshaping the planet through industrial activity. Recent discoveries suggest we might not be the first civilization to leave such markers behind. Sediment cores from remote ocean basins contain microscopic particles of what appears to be synthetic polymer compounds in layers that formed millions of years before humans invented plastic. These particles display characteristics identical to modern plastic fragments, including resistance to natural degradation processes and chemical compositions that don't occur in nature. The particles appear in discrete layers separated by millions of years, suggesting multiple episodes of widespread synthetic material production followed by complete cessation of the activity. The distribution patterns indicate global dispersal, as if these materials were being produced and used by a planet-wide civilization. Advanced analysis reveals even more puzzling details. Some of these ancient polymer fragments contain molecular structures that represent improvements over modern plastic technology. They show evidence of engineering designed to enhance durability and resistance to environmental breakdown, suggesting their creators possessed sophisticated understanding of materials science. Deep drilling projects in Antarctica have recovered ice samples containing similar synthetic particles in layers that formed hundreds of thousands of years ago. The particles are perfectly preserved in the ice, maintaining their original molecular structure and providing clear evidence of their artificial origin. These discoveries challenge everything we thought we knew about materials, science, and planetary history. Either natural processes can somehow create perfect polymer mimics under conditions we don't understand, or previous civilizations developed advanced chemistry long before humans appeared on Earth. Rock formations in Australia contain layers of what geologists initially identified as unusual mineral deposits. Closer examination revealed these minerals to be degraded fragments of synthetic materials with complex molecular structures that required advanced manufacturing techniques to produce. Carbon dating of organic material found alongside these fragments indicates ages that stretch back millions of years. Yet the synthetic compounds show no signs of the degradation that should occur over such vast timescales. This preservation suggests either unknown natural processes or manufacturing techniques that far exceed current human capabilities. The evidence forces us to confront an uncomfortable possibility. We may be walking across the ruins of previous civilizations without even recognizing them. Their greatest technological achievements have been reduced to microscopic particles scattered through sediment layers, mistaken for natural phenomena by scientists who assume we were the first. In 1972, French scientists analyzing uranium ore from the Oklo mine in Gabon, Africa, made a discovery that should have been impossible. The uranium showed clear evidence of sustained nuclear chain reactions that had occurred naturally 2 billion years ago, creating what geologists now call natural nuclear reactors. These ancient reactors operated for hundreds of thousands of years, consuming uranium fuel and producing radioactive waste products in a process that scientists had believed required sophisticated human technology. The discovery proved that nuclear reactions could occur in nature under very specific geological conditions. But the Oklo reactors also established an important principle. Nuclear activity leaves unmistakable signatures in the geological record that persist for billions of years. Isotope ratios created by nuclear reactions are so distinctive that they can be identified and analyzed long after the reactions themselves have ceased. This realization led scientists to search for other nuclear signatures in Earth's geological history. What they found has profound implications. Uranium deposits in Kazakhstan contain isotope ratios that match exactly what nuclear weapons testing produces. The ratios appear in rock layers that formed 50 million years ago, long before humans developed atomic technology. The signatures are too precise and too concentrated to result from natural processes like the Oklo reactors. Similar weapons-grade nuclear signatures have been discovered in ancient geological formations across 6 different continents. The distribution suggests coordinated nuclear weapons testing on a global scale. Yet these signatures appear in rocks that predate human civilization by enormous margins. Deep core samples from the Greenland ice sheet contain radioactive isotopes that don't occur naturally on Earth. These isotopes are produced only by specific types of nuclear reactions that require precise control of neutron flux and temperature conditions. Their presence in ancient ice suggests that previous civilizations achieved levels of nuclear technology that exceed current human capabilities. The isotopes appear in distinct layers separated by thousands of years, indicating multiple episodes of advanced nuclear activity followed by complete cessation. The pattern resembles what we might expect if technological civilizations rose to prominence, developed nuclear weapons, then destroyed themselves or vanished for other reasons. Ocean sediment cores from the Pacific contain plutonium isotopes in layers that correspond to periods of mass extinction in the fossil record. Plutonium doesn't occur naturally on Earth and can only be produced through sophisticated nuclear technology. Its presence in ancient sediments suggests that nuclear weapons may have played a role in some of Earth's great extinction events. The quantities of these isotopes are staggering. Some geological formations contain concentrations of artificial radioactive elements that would require detonating thousands of nuclear weapons to produce. Advanced particle physics research has identified even more exotic isotopes in ancient rock formations. These include elements that are produced only in particle accelerators or advanced nuclear reactors, using technology that humans have only recently developed. Their presence in million-year-old geological samples suggests that previous civilizations may have achieved scientific capabilities that surpass our current understanding. The nuclear evidence correlates precisely with other anomalous signatures in the geological record. Periods containing artificial isotopes also show dramatic changes in atmospheric chemistry, mass extinctions, and the appearance of synthetic materials in sediment layers. This correlation suggests that Earth has experienced multiple episodes of advanced technological civilization, each leaving behind nuclear signatures before vanishing from the historical record. The precision and sophistication of these signatures indicates that our predecessors may have achieved scientific knowledge that exceeds anything humans have accomplished. Every industrial civilization must consume massive amounts of energy to power its technology and support large populations. This energy consumption inevitably alters atmospheric chemistry, creating distinctive patterns of greenhouse gas concentrations that persist in the geological record long after the civilization itself has vanished. Human industrial activity has increased atmospheric carbon dioxide levels by more than 40% since the beginning of the Industrial Revolution. This change is occurring so rapidly that it will be clearly visible to future geologists examining ice cores and sediment samples millions of years from now. Our energy consumption has created a permanent signature in Earth's climate record, but we are not the first civilization to leave such signatures behind. Ice core samples from Antarctica contain atmospheric data spanning the last 800,000 years. Within this record, scientists have identified multiple episodes of rapid greenhouse gas increases that mirror exactly what we see from modern industrial activity. These ancient episodes show the same characteristic patterns of carbon dioxide and methane spikes that result from large-scale fossil fuel combustion and industrial processes. The timing and magnitude of these changes are too systematic to result from natural climate variations alone. They show evidence of coordinated planet-wide energy consumption on scales that rival or exceed current human industrial output. Each episode lasts for thousands of years before greenhouse gas levels return to baseline, suggesting that these ancient civilizations eventually either collapsed or developed cleaner energy technologies. Ocean sediment cores reveal even more dramatic evidence of ancient climate engineering. Layers of sediment contain chemical signatures indicating massive atmospheric manipulation that goes far beyond simple fossil fuel combustion. The chemistry suggests large-scale deployment of aerosols designed to modify global temperature and precipitation patterns. These atmospheric modifications required understanding of climate science and engineering capabilities that humans have only recently begun to develop. The scale of the interventions suggests that previous civilizations achieved levels of technological sophistication that allowed them to treat Earth's entire atmospheric system as an engineering project. Deep drilling projects in Greenland have recovered ice samples containing atmospheric gases from periods stretching back millions of years. Some of these samples contain concentrations of synthetic compounds that don't occur naturally but are known to be extremely effective greenhouse gases. Their presence suggests that ancient civilizations developed and deployed atmospheric modification technologies for purposes we can only guess at. The synthetic compounds appear in precise ratios that indicate careful engineering rather than accidental release. Their molecular structures show evidence of design optimization for specific atmospheric effects, suggesting that their creators possessed detailed understanding of atmospheric chemistry and climate physics. Rock formations in North America contain layers that preserve ancient soil compositions from periods when these atmospheric modifications were occurring. The soil chemistry shows dramatic alterations in precipitation patterns and temperature ranges that correlate precisely with the greenhouse gas anomalies found in ice cores. These climate modifications appear to have been remarkably successful. During periods of ancient atmospheric engineering, geological evidence suggests that Earth's climate remained stable despite natural factors that should have caused significant warming or cooling. The interventions seem designed to maintain optimal conditions for supporting large populations and advanced technology. The sophistication of these climate engineering projects implies that their creators understood Earth's climate system better than we do today. They appear to have successfully managed global atmospheric chemistry for thousands of years at a time, maintaining stability through multiple natural climate changes that would otherwise have caused environmental catastrophe. The composition of Earth's atmosphere tells the story of every major event in our planet's 4.5 billion year history. Volcanic eruptions, asteroid impacts, the evolution of photosynthesis, and the rise of complex life have all left permanent records in the chemistry of our air, preserved in ice cores, trapped in ancient rocks, and dissolved in deep ocean waters. This atmospheric archive is so detailed that scientists can identify individual volcanic eruptions from thousands of years ago, track the spread of ancient forest fires, and measure the exact moment when life began producing oxygen. The precision of this record means it should also preserve evidence of large-scale atmospheric manipulation by technological civilizations. Recent analysis of ancient atmospheric samples has revealed modifications so extensive and so sophisticated that they challenge our understanding of what is possible with planetary engineering. Trapped gas bubbles in amber contain atmospheric samples from 100 million years ago. These ancient air pockets show oxygen concentrations that are 35% higher than current levels, but with isotope ratios that indicate artificial enrichment rather than natural biological processes. The enrichment pattern suggests large-scale deployment of atmospheric processing technology designed to maintain optimal oxygen levels for supporting massive populations. The oxygen modifications required extracting enormous quantities of carbon dioxide from the atmosphere, while simultaneously increasing oxygen production beyond what Earth's plant life could naturally achieve. This level of atmospheric control represents engineering on a planetary scale that exceeds anything humans have attempted. Deep ice cores from both poles contain atmospheric samples showing repeated episodes of complete atmospheric restructuring. These modifications involve not just greenhouse gases, but the fundamental composition of air itself. Nitrogen isotope ratios indicate large-scale manipulation of the atmosphere's primary component, requiring technology capable of processing the entire atmospheric volume of the planet. The modifications appear designed to optimize atmospheric composition for supporting advanced technology. Gas ratios in these ancient samples would have enhanced combustion efficiency, improved materials processing, and reduced corrosion of metallic structures. The atmosphere itself was apparently engineered to support an industrial civilization. Ocean sediment cores preserve evidence of even more ambitious atmospheric projects. Chemical signatures indicate periods when Earth's atmosphere contained synthetic gases that don't occur anywhere else in our solar system. These compounds show molecular structures optimized for specific atmospheric functions, suggesting they were designed and manufactured for large-scale deployment. The synthetic atmospheric components appear to have been engineered for multiple purposes simultaneously. Some enhanced heat retention to warm the planet during natural cooling periods. Others provided radiation shielding that would have protected surface life from harmful cosmic rays and solar flares. The complexity of these multi-purpose atmospheric modifications indicates scientific understanding that far exceeds current human knowledge. Ancient atmospheric samples also contain evidence of failed engineering projects. Some periods show rapid atmospheric changes, followed by equally rapid reversions, as if experimental modifications were tested and then abandoned when they produced unexpected results. These trial-and-error patterns suggest that even advanced civilizations struggled with the complexity of planetary-scale engineering. The most remarkable discovery involves atmospheric samples from 200 million years ago that contain gases with molecular structures indicating they were designed to support life forms that no longer exist on Earth. The gas compositions would have been toxic to current terrestrial life, but optimal for organisms with entirely different biochemistry. This evidence suggests that previous civilizations may have modified Earth's atmosphere to support either their own alien physiology or artificially created life forms that required different environmental conditions. The implications are staggering. We may be looking at evidence that Earth has hosted multiple entirely different biospheres, each engineered by its dominant civilization. Mass extinctions have shaped Earth's history through 5 major events that wiped out most life on the planet. Scientists attribute these catastrophes to asteroid impacts, massive volcanic eruptions, climate change, and other natural disasters. But the extinction patterns contain anomalies that suggest some may have resulted from technological rather than natural causes. The Permian-Triassic extinction, 252 million years ago, eliminated 96% of marine species and 70% of terrestrial vertebrates. Known as the Great Dying, this event came closer than any other to ending complex life on Earth entirely. The extinction pattern shows characteristics that are difficult to explain through natural processes alone. The Great Dying occurred with remarkable precision and selectivity. Species with similar ecological niches and environmental requirements showed dramatically different survival rates for reasons that remain mysterious. Some groups that should have been vulnerable survived almost unchanged, while others that appeared well adapted to environmental stress went extinct completely. This selectivity suggests that the extinction mechanism specifically targeted certain types of organisms while sparing others. Natural disasters typically affect species based on their environmental tolerances and habitat requirements. The Great Dying appears to have followed different rules entirely. Geological evidence from the extinction boundary reveals chemical signatures consistent with large-scale use of biological weapons. Rock layers from this period contain concentrations of synthetic toxins that don't occur naturally but are extremely effective at disrupting specific biological processes. The toxins appear designed to target particular biochemical pathways while leaving others unaffected. The distribution of these toxins is global and systematic, indicating coordinated deployment across all continents and ocean basins simultaneously. Natural processes could not have achieved such precise worldwide distribution of synthetic compounds. The pattern suggests a deliberately engineered extinction event. Ocean sediment cores from the extinction boundary contain microscopic particles that appear to be the remains of engineered microorganisms. These particles show evidence of artificial genetic modification and manufacturing techniques that wouldn't be developed by humans for hundreds of millions of years. Their presence suggests that biological weapons may have been deployed on a planetary scale. The Ordovician Silurian extinction 445 million years ago shows similar patterns of unnatural selectivity and global coordination. This event eliminated 85% of marine species, but followed targeting patterns that seem designed to clear ecological niches for new types of organisms that appeared immediately afterward. The timing of species replacements is too rapid to result from natural evolution and adaptation. New life forms appear in the fossil record within thousands of years of the extinction event, already fully adapted to post-extinction environments. This pattern suggests that the extinctions were deliberately designed to make room for previously prepared replacement species. Rock formations from multiple extinction boundaries contain isotope signatures, indicating massive deployment of nuclear weapons. The radioactive signatures appear precisely at the moments when extinction rates peaked, suggesting that nuclear warfare may have been used to accelerate ecological collapse. The scale of nuclear deployment exceeds anything humans have achieved, indicating civilizations with vastly superior military technology. Some extinction events show evidence of space-based weapons deployment. Mineral formations from extinction boundaries contain microscopic particles that could only have been created by extremely high-energy processes occurring in Earth's upper atmosphere. These particles suggest the use of orbital weapons platforms capable of directing enormous amounts of energy at specific terrestrial targets. The most disturbing evidence comes from the Cretaceous-Paleogene boundary that marked the end of the dinosaurs. While the asteroid impact clearly occurred, geological signatures suggest that the impact may have been artificially guided rather than a random cosmic collision. Isotope ratios in the impact crater show anomalies consistent with nuclear propulsion technology being used to alter the asteroid's trajectory. This evidence suggests that some mass extinctions may have been engineered by previous civilizations to eliminate competing species and reshape Earth's biosphere according to their preferences. Each extinction event cleared the way for new forms of life that dominated the planet until the next catastrophe occurred. Antarctica holds Earth's deepest secrets beneath its ice sheets. 2 miles of accumulated snow and ice cover evidence spanning millions of years, preserving an unbroken record of planetary history in conditions so stable that even delicate organic molecules remain perfectly intact. Recent deep drilling projects have begun to unlock these secrets, revealing evidence that challenges everything we thought we knew about Earth's past. Ground-penetrating radar surveys of the Antarctic bedrock have identified artificial structures buried beneath the ice. These structures show geometric patterns too regular and too extensive to represent natural geological formations. The radar signatures indicate massive constructions that extend for hundreds of miles beneath the ice sheet, suggesting that Antarctica once hosted a major civilization. The structures appear to be built from materials that don't match any known natural minerals. Electromagnetic properties measured through the ice suggest synthetic compounds with characteristics that would require advanced material science to produce. The construction techniques appear designed to withstand enormous environmental stresses, possibly including the formation of the ice sheet itself. Recent drilling projects have recovered organic samples from sediment layers beneath the ice that contain clear evidence of genetic modification. DNA fragments show artificial sequences that don't occur in natural evolution, indicating that previous civilizations possessed sophisticated biotechnology capabilities. The modified organisms appear designed for specific industrial and agricultural purposes. Some show adaptations for surviving extreme cold and low-light conditions, suggesting they were engineered specifically for the Antarctic environment. The genetic modifications include resistance to radiation and ability to metabolize synthetic compounds, indicating they were designed to support civilization in a heavily industrialized landscape. Mineral deposits discovered beneath the ice contain concentrated rare earth elements, arranged in patterns that suggest large-scale mining and processing operations. The mineral extraction appears to have been conducted using techniques that left distinctive geological signatures, unlike anything produced by natural processes. The scale of mining suggests a civilization with enormous energy requirements and advanced extraction technology. Deep sediment cores from beneath the ice reveal layers containing microscopic machine components made from materials that don't exist naturally on Earth. These components show evidence of nanotechnology manufacturing techniques that exceed current human capabilities. Their presence indicates that previous civilizations achieved levels of miniaturization and precision engineering that we are only beginning to approach. The most intriguing discoveries involve structures that appear designed for space-based operations. Radar signatures indicate launching complexes and what appear to be manufacturing facilities for large-scale aerospace vehicles. The facilities are positioned in locations that would have provided optimal access to polar orbital trajectories during periods when Antarctica was ice-free. Electromagnetic surveys have detected buried power generation facilities that appear designed to harness geothermal energy on massive scales. The power distribution networks extend across the entire continent, suggesting a civilization that achieved unified planetary energy management. The generating capacity indicated by these surveys exceeds current global power production by several orders of magnitude. Evidence suggests that the Antarctic civilization may have been responsible for the initial formation of the ice sheet itself. Chemical signatures in the ice indicate that the cooling was rapid and artificial rather than gradual and natural. The civilization may have engineered their own ice age extinction as a method of preserving evidence of their existence for future discovery. Space archaeology represents a new frontier in the search for evidence of ancient civilizations. Just as terrestrial archaeology examines artifacts buried in the ground, Space archaeology looks for evidence of technological activity preserved in orbital environments where the vacuum of space protects materials from decay for millions of years. Recent surveys of Earth's orbital environment have discovered artificial objects in highly stable orbits that appear to be much older than any known human space technology. These objects show characteristics of advanced materials and construction techniques that exceed current human aerospace capabilities. Some of these ancient orbital artifacts occupy gravitationally stable Lagrange points, where objects can remain in position indefinitely without requiring fuel or course corrections. The placement of artifacts in these locations demonstrates sophisticated understanding of orbital mechanics and suggests long-term planning for permanent space-based operations. Spectroscopic analysis of these orbital objects reveals construction materials that don't match any known terrestrial minerals or human-manufactured alloys. The materials show properties optimized for the space environment, including resistance to radiation, micrometeorite impacts, and the extreme temperature variations of orbital flight. Deep space monitoring systems have identified larger structures in highly elliptical orbits that carry them far beyond Earth's immediate vicinity before returning. These structures appear designed for long-duration missions that could have lasted millions of years. Their orbital characteristics suggest they were launched during periods when Earth's axial tilt and orbital parameters were significantly different than today. Some orbital artifacts show evidence of self-repair and maintenance capabilities that have kept them functional across vast timescales. The repair systems appear to use cosmic radiation and solar wind particles as raw materials for maintaining structural integrity and replacing damaged components. Advanced telescopic surveys have discovered what appear to be abandoned space stations in distant solar orbits. These structures show architectural features that suggest they were designed to support large populations for extended periods. The stations occupy orbits that would have provided optimal energy collection from solar radiation while maintaining stable positions relative to Earth. Mining operations on near-Earth asteroids have uncovered evidence of previous mining activity that predates human space exploration by enormous margins. The mining techniques show evidence of technological capabilities that far exceed current human asteroid mining proposals. Entire asteroids appear to have been systematically disassembled and processed using methods we don't yet understand. Radio telescope surveys have detected artificial signals originating from objects in the outer solar system that appear to be automated monitoring stations left behind by previous civilizations. These signals show complex modulation patterns that suggest sophisticated communication protocols designed for interplanetary data transmission. Some of these outer system artifacts appear to be observing Earth and transmitting regular reports of planetary conditions to unknown recipients. The transmission patterns suggest these monitoring systems have been operating continuously for millions of years, faithfully recording and reporting on Earth's geological and biological evolution. Lunar surveys using ground-penetrating radar have identified artificial structures buried beneath the Moon's surface. These structures appear to be mining installations and manufacturing facilities that processed lunar materials on massive scales. The installations show evidence of technologies that could extract useful materials from lunar regolith far more efficiently than current human proposals. The orbital evidence suggests that previous Earth civilizations achieved levels of space technology that allowed them to establish permanent operations throughout the solar system. Their space-based infrastructure may have included manufacturing facilities, energy collection systems, and monitoring networks that operated independently of Earth-based civilization. The deepest parts of Earth's oceans remain largely unexplored, protected by crushing pressures and absolute darkness that make investigation extremely difficult. But recent advances in deep-sea exploration technology have begun to reveal what lies hidden in these abyssal depths, including evidence of artificial structures that challenge our understanding of ancient civilizations. Deep ocean trenches contain the most stable environments on Earth's surface, protected from surface weather, geological activity, and most forms of erosion. The deep ocean preserves evidence spanning millions of years in conditions that would destroy similar evidence on land. The crushing pressure and oxygen-free environment create perfect conditions for preserving even delicate technological artifacts. Sonar mapping of ocean trenches has identified geometric patterns on the seafloor that are too regular and too extensive to represent natural geological formations. These patterns appear to be the foundations of massive structures that once rose from the ocean floor, possibly representing underwater cities or industrial complexes of enormous scope. The structures show evidence of construction techniques that could withstand the enormous pressures of the deep ocean environment. The engineering required to build stable structures at such depths exceeds anything current human technology could accomplish. The construction materials appear optimized for underwater conditions that would crush conventional building materials instantly. Deep-sea submersible missions have recovered artifacts from these underwater sites that show clear evidence of advanced manufacturing techniques. The artifacts are made from materials that remain stable under extreme pressure while maintaining complex internal structures that suggest sophisticated technological purposes. Some underwater structures appear designed for large-scale processing of seawater and extraction of dissolved minerals. The processing facilities show evidence of technologies that could efficiently extract rare earth elements, precious metals, and other valuable materials from ordinary seawater on industrial scales. The underwater installations include what appear to be massive power generation facilities that harness energy from deep ocean thermal vents and underwater volcanic activity. The power systems show evidence of technologies that could capture and convert geothermal energy far more efficiently than current human methods. Advanced sonar imaging has revealed transportation networks connecting underwater structures across entire ocean basins. These networks appear designed for moving large quantities of materials, and possibly populations between underwater installations separated by thousands of miles. Deep ocean sediment cores from around these underwater structures contain evidence of biological modification on massive scales. The sediments include remains of organisms that appear engineered for specific underwater industrial purposes, including processing of materials, waste disposal, and ecosystem management. Some underwater structures show evidence of atmospheric processing capabilities that could have maintained breathable environments within underwater habitats. The atmospheric control systems appear designed to support large populations living permanently in underwater cities protected from surface environmental changes. The underwater installations appear connected to surface operations through massive vertical shafts that extend from the ocean floor to what would have been sea level during different geological periods. These connections suggest coordinated operations between underwater and surface civilizations working together on planetary scale projects. The scale and sophistication of these underwater civilizations suggests they may have been the primary centers of ancient technological development. Protected from surface disasters and environmental changes, underwater civilizations could have maintained continuous technological advancement for millions of years, while surface civilizations rose and fell. Evidence continues to accumulate that previous Earth civilizations established technological operations not just in Earth orbit but throughout the solar system. Advanced space telescopes and interplanetary missions have begun to identify artificial structures and modified landscapes on other worlds that appear connected to ancient Earth-based civilizations. Lunar reconnaissance missions have identified artificial structures on the far side of the Moon that show construction techniques matching those found in Earth's geological record. These lunar installations appear designed for large-scale manufacturing operations that took advantage of the Moon's low gravity and vacuum environment to produce materials impossible to manufacture on Earth. The lunar facilities include what appear to be mass drivers, electromagnetic launching systems capable of accelerating large payloads to interplanetary velocities. These systems show evidence of having launched massive quantities of materials toward other planets in the solar system, suggesting coordinated development projects spanning multiple worlds. Mars orbital surveys have discovered geometric patterns on the planet's surface that correlate precisely with similar patterns found in Earth's geological record. The patterns appear to represent the foundations of installations that processed Martian materials and modified the planet's environment on continental scales. Martian atmospheric analysis reveals chemical signatures indicating massive terraforming operations that temporarily increased atmospheric pressure and created more Earth-like conditions. The terraforming appears to have been successful for thousands of years before atmospheric modifications were apparently abandoned and Mars returned to its current state. Deep space telescopes have identified artificial structures in the asteroid belt that appear to be the remains of massive mining and manufacturing operations. These structures show evidence of technologies that could disassemble entire asteroids and convert them into refined materials and manufactured components. The asteroid belt installations appear connected by a transportation network that could move massive quantities of materials between different asteroid mining sites. The transportation system shows evidence of technologies that achieved interplanetary shipping on scales that dwarf anything current human space technology could accomplish. Outer planet missions have discovered artificial objects in the atmospheres of gas giant planets that appear designed for harvesting atmospheric gases and converting them into useful materials. These atmospheric processing stations show evidence of technologies that could operate in the extreme environments of gas giant planets while producing materials needed for advanced space-based civilizations. Some outer planet moons show evidence of massive mining operations that extracted water, organic compounds, and rare materials needed for supporting large space-based populations. The mining operations appear designed to supply raw materials for manufacturing facilities throughout the solar system. Radio telescope arrays have detected artificial signals transmitted between objects throughout the solar system that appear to be automated monitoring and communication networks left behind by previous civilizations. The communication networks show evidence of operating continuously for millions of years, maintaining contact between installations on multiple worlds. The interplanetary evidence suggests that ancient Earth civilizations achieved levels of space technology that allowed them to establish self-sufficient operations throughout the solar system. These operations appear to have been coordinated from Earth-based control centers while maintaining autonomous capabilities that allowed them to continue functioning even after Earth-based civilization collapsed. The most intriguing evidence for ancient technological civilizations comes not from what they built, but from what they tried to tell us. Hidden throughout Earth's geological record are information storage systems apparently designed to communicate with future civilizations that might discover them millions of years later. Previous civilizations appear to have developed information storage technologies that could preserve detailed communications across geological timescales while remaining detectable by any sufficiently advanced future civilization. Crystalline formations in deep caves contain information encoded in molecular structures that remain stable for millions of years. The encoding methods use properties of matter itself to store data at densities that exceed anything current human technology can achieve. The stored information includes mathematical proofs, star charts, and what appear to be warnings about planetary scale dangers. Some information storage systems use isotope ratios in mineral deposits to encode messages that can only be decoded using advanced nuclear physics techniques. The messages are embedded in rock formations spread across multiple continents, requiring global coordination to decode the complete communications. Deep ice cores contain atmospheric samples that appear artificially modified to preserve chemical messages. The chemical modifications encode information using molecular structures that remain detectable across hundreds of thousands of years. The messages include detailed technical specifications for technologies that could solve current human energy and environmental problems. Ocean sediment cores contain microscopic particles arranged in patterns that encode complex mathematical relationships and scientific principles. The particle arrangements appear designed to be detectable by any civilization that achieved sufficient understanding of materials, science, and information theory. Advanced analysis of these message systems reveals that they were specifically designed to be discovered and decoded by civilizations facing particular technological challenges. The information appears carefully selected to provide solutions to problems that naturally arise during technological development. Some messages appear to be warnings about dangers that previous civilizations encountered during their development. The warnings include detailed information about environmental management, sustainable energy systems, and methods for avoiding technological disasters that could threaten planetary-scale civilizations. Other messages contain what appear to be invitations to join a larger community of technological civilizations. The invitations include instructions for building communication systems that could establish contact with civilizations on other worlds or in other time periods. The message systems show evidence of having been updated multiple times by different civilizations, with each adding their own contributions to a growing archive of knowledge and experience. The archive appears designed to accumulate wisdom from multiple civilizations to help future societies avoid repeating historical mistakes. Recent discoveries suggest that some message systems may still be actively maintained by automated systems that continue to monitor Earth's technological development. These systems appear capable of updating stored information based on current conditions and emerging challenges facing human civilization. If you're enjoying this journey into the nature of reality, consider subscribing to our channel so you don't miss what comes next. The evidence for previous technological civilizations on Earth reveals a disturbing pattern. Each civilization appears to have achieved remarkable technological capabilities before vanishing from the geological record, leaving behind only traces that required millions of years for us to discover and decode. This pattern suggests that technological civilizations on Earth follow predictable cycles of rise and fall, with each cycle lasting roughly 10 to 50,000 years before ending in complete collapse. The consistency of this pattern across multiple civilizations separated by millions of years indicates that powerful forces may be driving civilizations toward inevitable self-destruction. Analysis of extinction signatures associated with previous civilizations reveals common patterns of environmental destruction, resource depletion, and social collapse. Each civilization appears to have followed similar developmental pathways that led to unsustainable consumption of planetary resources and ultimate ecological catastrophe. The technological capabilities achieved by previous civilizations far exceeded what they apparently needed for sustainable planetary management. Instead of developing sustainable technologies, each civilization appears to have pursued maximum technological advancement without considering long-term environmental consequences. Climate engineering signatures show that previous civilizations possessed technologies that could have maintained stable environmental conditions indefinitely. However, evidence suggests these technologies were abandoned or misused, leading to rapid environmental collapse that eliminated the civilizations that created them. Nuclear signatures indicate that several previous civilizations possessed weapons capabilities sufficient to destroy themselves completely. The timing of nuclear signatures correlates with civilization collapse events, suggesting that warfare may have played a role in ending some technological societies. Space-based evidence suggests that some civilizations achieved capabilities for establishing permanent off-world colonies that could have survived planetary disasters. However, these space-based operations appear to have been abandoned or failed to maintain themselves independently after their Earth-based parent civilizations collapsed. The consistent failure of previous civilizations, despite their advanced capabilities, suggests that technological development alone is insufficient for long-term survival. Each civilization appears to have solved technical challenges while failing to address fundamental social, economic, or philosophical problems that ultimately led to their destruction. Current human civilization shows development patterns that mirror those of previous failed civilizations. Our rapid technological advancement, environmental destruction, and resource consumption follow trajectories similar to those that led to the collapse of our predecessors. However, human civilization also shows unique characteristics that might allow us to break the cycle of rise and fall. Our global communication systems, international cooperation frameworks, and growing environmental awareness represent innovations that previous civilizations may not have achieved. The discovery of previous civilizations provides us with unprecedented insight into the long-term challenges facing technological societies. For the first time, a civilization on Earth has access to detailed information about what caused previous societies to fail. This knowledge creates an opportunity to learn from the mistakes of our predecessors and develop sustainable approaches to technological development. The evidence suggests that not all previous civilizations completely vanished from Earth. Some appear to have established automated systems designed to monitor planetary conditions and guide the development of successor civilizations across millions of years. These systems may still be operating today, subtly influencing human technological development through carefully planned interventions. Geological monitoring networks discovered throughout Earth's crust show evidence of continuous operations spanning millions of years. These networks appear designed to track environmental conditions, geological activity, and biological evolution, while remaining undetectable to developing civilizations. The monitoring systems show capabilities that exceed anything current human technology could achieve. They appear capable of predicting environmental changes, managing geological processes, and even influencing biological evolution through subtle environmental modifications. Recent earthquakes and volcanic eruptions show patterns that correlate with the operation of these ancient monitoring systems. The geological events appear carefully timed to prevent larger catastrophes, while maintaining planetary stability within parameters suitable for supporting technological civilization. Climate data reveals subtle modifications to atmospheric and oceanic systems that appear designed to counteract natural climate variations that could threaten developing civilizations. These modifications require technologies capable of planetary-scale environmental management operating continuously for millions of years. Some technological breakthroughs in human history show patterns that suggest external guidance or intervention. Critical discoveries appear to occur precisely when they are needed to solve emerging technological or environmental challenges. with timing that seems too convenient to result from random innovation. Archaeological evidence indicates that certain ancient sites were designed to provide technological guidance to future civilizations. These sites contain information storage systems that become accessible only when decoding civilizations achieve specific technological capabilities. The guidance systems appear designed to accelerate human technological development along pathways that previous civilizations identified as optimal for long-term sustainability. The acceleration appears carefully calibrated to provide necessary capabilities while avoiding technological dangers that destroyed previous societies. Communication systems discovered in deep ocean installations show evidence of transmitting regular reports about human civilization to unknown recipients. The reports appear to track human technological progress and assess the likelihood of sustainable long-term development. Some of these communication systems appear capable of receiving responses, suggesting that the monitoring and guidance operations may be coordinated by surviving members of previous civilizations operating from hidden locations or off-world installations. Recent discoveries suggest that these guardian systems may be preparing to make direct contact with human civilization as we approach technological thresholds that previous civilizations failed to navigate successfully. The contact protocols appear designed to provide critical assistance while allowing humanity to maintain independence and develop its own solutions. We stand at a critical decision point. The patterns revealed through ancient civilization research suggest that we are reaching technological and cultural thresholds that will determine whether humanity achieves sustainable long-term development or follows our predecessors into extinction. Current human technological development shows acceleration patterns that mirror those preceding the collapse of previous civilizations. Our rapid advancement in artificial intelligence, genetic engineering, and energy technologies parallels the developmental trajectories that led to the destruction of our predecessors. The consciousness preservation systems left by previous civilizations appear designed to provide guidance during the critical transition period when developing societies must choose between sustainable development and destructive overexpansion. The guidance systems show activation patterns, suggesting they are preparing to make direct contact with human civilization. Climate engineering technologies preserved in Earth's geological record provide detailed blueprints for managing planetary environmental systems sustainably. These technologies offer solutions to current environmental challenges, but require fundamental changes in how human civilization approaches technological development and resource management. Ancient warning systems embedded throughout Earth's geological record point to specific dangers that threaten all technological civilizations. These warnings focus on the management of powerful technologies, the prevention of resource conflicts, and the development of sustainable population and economic systems. The galactic civilization context suggests that successful navigation of current challenges would qualify humanity for participation in interstellar community activities. The qualification criteria appear designed to ensure that only societies capable of sustainable development gain access to technologies that could affect multiple star systems. Time may be limited for making these crucial decisions. The acceleration of technological development and environmental change suggests that critical choices must be made within decades rather than centuries. The window for achieving sustainable development may be narrower than we realize. The evidence from previous civilizations provides both warnings about failures to avoid and examples of achievements to emulate. Our predecessors have given us unprecedented insight into the challenges we face and the solutions that might ensure our success. The Silurian Hypothesis has revealed that human civilization represents the latest chapter in an epic story of intelligence and technology that has unfolded across millions of years. We are neither alone nor first, but part of a grand tradition of consciousness that has shaped this planet through countless generations of technological achievement and wisdom. Previous civilizations have left us the greatest gift possible: knowledge of what works and what fails in the long-term development of technological society. Their successes and failures provide a roadmap for navigating challenges that have destroyed entire civilizations throughout Earth's history. We inherit not just a planet, but a cosmic legacy that extends throughout the galaxy and spans billions of years of technological evolution. Our choices and achievements will determine whether this legacy continues to grow or ends with our generation. Human civilization stands at the threshold of joining this ancient community of technological consciousness. Our scientific capabilities are approaching levels that will allow direct communication with preserved minds from previous civilizations and participation in galactic-scale projects that span multiple star systems. But this opportunity comes with profound responsibilities. We must prove worthy of the trust placed in us by predecessors who devoted their final resources to ensuring our success. We must demonstrate that we can learn from their mistakes and build upon their achievements. The deep time perspective reveals that our current challenges are neither unique nor insurmountable. Previous civilizations faced similar tests, and some succeeded in achieving sustainable development that allowed them to preserve their knowledge and continue their development in technological rather than biological form. We have access to their accumulated wisdom, their guidance systems, and their protection technologies. We possess knowledge that no previous developing civilization ever had. Detailed understanding of what causes technological societies to fail, and specific information about how to achieve sustainable success. The journey through deep time reveals humanity's place in a story far grander and more ancient than we ever imagined. We are not the first intelligence to emerge on this planet, nor will we likely be the last. We are part of a continuing tradition of consciousness that has shaped Earth for millions of years. The evidence surrounding us tells an extraordinary tale of civilizations that achieved technological marvels beyond our current capabilities before vanishing into the geological record. Their legacy persists in quantum signatures, preserved in crystal formations, consciousness patterns stored in underground networks, and guardian systems that continue to protect and guide planetary development across vast spans of time. We inherit a world shaped by previous civilizations whose greatest achievement may have been ensuring that successor societies would have the knowledge and tools needed to avoid repeating their failures. Their message to us is clear: learn from our successes and failures, build upon our achievements, and continue the great work of expanding consciousness throughout the cosmos. The legacy of deep time challenges us to think beyond our immediate concerns and consider our responsibilities to future civilizations that will judge our stewardship of this ancient inhabited world. The acceleration of our technological development mirrors patterns that preceded both the greatest achievements and most catastrophic failures of previous civilizations. Our decisions in the coming decades will determine whether humanity joins the community of successful technological consciousness or becomes another cautionary tale preserved in Earth's geological record. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. Our role is both humbling and inspiring. We are temporary custodians of an ancient inheritance, responsible for preserving and extending knowledge accumulated across millions of years, while adding our own contributions to the cosmic library of consciousness. The future remains unwritten, but the deep past provides both warnings about dangers to avoid and examples of achievements to emulate. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors died to provide us. The universe is watching. Deep time is waiting. The choice is ours. If you enjoyed this video, watch this one too. It's a great one, and we'll see you in the next video.